Hello YouTube, this is Alexander again. Today is a kind of repair day, at least we try. This amplifier on the bench is AX-E71 stereo integrated amplifier, and it's an unusual amplifier coming from the 80s or the 90s. It's a very nice amplifier. According the music you can listen, because this kind of amplifier are not the best for to listen loud music. They are some kind of classical amplifier, and this kind of amplifier has a very nice sound. They use STK integrated circuit to make this amplifier working very easy. This is a monolithic integrated circuit, and in the 90s, and I think nowadays they can use some integrated circuit like this one. As you can see here, this integrated circuit is pretty dismounted from the heatsink and other stuff around to make easy some troubleshooting on it. So this amplifier was given to me by a friend, and unfortunately he makes some description about that, about the trouble he presents, and unfortunately when I have it between my hands, he finally died between my hands, on my hands. So I didn't have so much time to make some troubleshooting, because the reaction which was described to me by the owner of this amplifier was not exactly the same than I was expected on the bench. So it make the troubleshooting more difficult, and some hesitation about how to proceed, because visually at first sight those kind of amplifier didn't present any trouble, and it was very hard to make some troubleshooting on it. And so this is the reason why I made this video, because the trouble discovered on this amplifier was very tricky actually, because it's unusual trouble. So to talk about this amplifier, this is a JVC, which is a very nice brand, and with a remote knob about sounds. It's a very nice piece of technology to have to listen music. Actually, I think those kind of device are perfect to listen classical music, and always not dance music, and some R&B music contain lots of bass and etc. Those kind of amplifier comes from the 80s and 90s, and they are perfect to listen classical music. The owner of this amplifier, for to tell the story about that, is a lover about old music. Ancient music are always listened by a lot of people, and they always used those kind of old amplifier with cassettes, turntable, etc. to listen to music coming from the whole days. So to present this amplifier, you can see it has a serious entry here, and you can connect it to video input and DAT, digital audio. You can use CD and other stuff like this, and it has the possibility to connect many speakers. Of course, we usually need to be very cautious with this kind of output. If not, you can destroy and you can provoke the demise of the integrated circuit, which is very sensitive to the terminal load. Actually here, this kind of amplifier can be destroyed very easily, just because you put a 4 ohm speaker until and no 8 ohm speaker on the terminal here. They are actually very fragile. So you have also some outlet here to connect other elements, which comes or over or under this element according tuner or many other plugins you can use with this amplifier. This is a classical Class B amplifier, and let's change point of view. Okay, from this camera you can see here the main transformer which is used to give the main power to the output speakers and the output to the main board. And also you can see a very low transformer which is here. This is a very low power transformer, and this very low power is used here to provide the energy which is necessary to the remote control sensor, which is always connected to the main, because he's waiting an order from the remote to switch on, switch off, or to change channel and turn the volume on or off. So the first attempt was to me to change this fuse, because there was stated like dead fuse, but it was useless, because even the fuse was changed, we have absolutely no consumption on this power supply. You can see here there is absolutely no current, and you can see this is the maximal protection here, and if there is any short circuit you will have a light coming from this giant LED here. So there is absolutely no much current going through this amplifier, which is mainly a power failure actually. So the first attempt was to check some component here. I'm going to show you. So to talk about the troubleshooting I begin with was, of course, the check of the DC voltage on the power supply coming from this little transformer. I make some research with the oscilloscope and find a bad signal on the capacitor. Firstly, I thought this capacitor was not working because I had a serious alternative component on the DC supply, which I am going to show you. And first I changed the capacitors, which was this one at first time. This is the original capacitors, because I found a very bad composite. It was an alternative DC voltage on the capacitors, which indicates to me that the filtering effect was not done by these capacitors. So of course I tried to make different capacitors, because I tried to make a better filtering, but it was useless, because I put always a lower capacitor and it also make the job. So I put the same, as you can see here, the same capacitors with the same capacity, but a little bit more voltage, which is better to resist during its work, as long as it will live again. So I'm going to show you the sine wave on this component, which was it was fooling me, because I was making a bad troubleshooting, and I'm going to show you the signal which was here actually. You can see here the signal coming from the DC output of this bridge diode, and you can see there is a very strange, a very bad here sine wave, which indicates to me that there is absolutely no filtering. And because this sine wave, I changed the capacitors, but absolutely it's give no results on this amplifier. Actually, maybe there is a component between the capacitor and the output diode here, and it can explain why this sine wave which is fooling you when you're troubleshooting actually. So actually this power supply and this transformer, according the bridge diode and the capacitors was okay. Here all of those transistors here are for the regulation process. This one is actually a regulator process to provide regulated voltage to the main board here. I didn't know this firstly, but I discovered it when I was troubleshooting. So what I made here for to explain, I dismounted this little transistor here. So here what you can see those very little transistor here, which they have a very exotic voltage between the emitter and base, and I suspected that it was not a NPN but PNP transistor maybe, but I dismounted and I desoldered and I desoldered it and tested on those kind of device, which was very nice for testing transistor, and it told me that the transistor was very good actually. So also I dismounted this one. You can see here this one which is a NPN transistor also, and this kind of NPN looks like a relay on this PCB to connect, but this is actually, it's described on the datasheet like a switch on, switch off, but actually it's used like, this transistor is used like a regulated power supply, because you can see nearly besides some Zener diodes and resistor here, which indicates that this transistor work like a regulator here. So I was looking about some voltage here, and you can see some traps. I don't know if you can see, but there is actually here some traps, and those traps are the 12 volts coming from some regulator on the right of the PCB to feed the turntable, because this amplifier has an outlet to feed an external turntable, and this is the power supply. Firstly, when you try to connect this amplifier to the main, you will not have 12 volt like described on the PCB here, which indicates that this PCB is not powered at all, and there is some issue coming from this part here, which is the main thing to check, because if this main board is not switching on, it's because you have here some relay. This relay is commanded by this little transformer and some transistor also by the remote control board to switch on the big transformer. And the little relay you can see here is the relay which is able to wait a little bit when you connect this amplifier to prevent the speaker about some plop when you switch on the amplifier. So when you connect this amplifier to the main, you will have no sign of life about this device here. But as I was telling from the start, the first time I connected, this amplifier has some sign of life. And after the first connection to the main, he didn't give any sign of life. So he was died on my hands, and can make some trouble. This kind of trouble can give you serious trouble with the owner, because he gives you a dying amplifier, but not totally dying, and you need to explain, if you don't found the trouble on this amplifier, you need to explain then this amplifier was not working like described before you have it on your bench. So you can, this kind of stuff can mix you in serious trouble with the owner. So fortunately, I was looking on the good area, because mainly if the power supply didn't switch on, it's because this main power supply has a failure. So the purpose of this video is to explain to you that this failure can be very ominous, and it was very hard to me, because I struggled several days and several evenings to try to understand why this amplifier, which is like at first sight very simple, but it has a lot of stuff on it. And actually, if you don't found any trouble on the power supply, you will not found some trouble on the logic board, which is very sophisticated. Actually, you will have here a first logic board, which is able to choose between the entry of this amplifier to connect it on the main integrated circuit, and you will have some data line, as you can see here. It's written on the PCB, which is actually, this is a very technological way, because sometimes they use simple relay to connect between an entry and another one. Also, you will have here another logic board here, and this is the infrared board, which commands the motorized potentiometer, and also you will have here you will have some regulator, which and this one is the one who gives the 12 volt to the turntable on the front back here. On the back, there is a 12 volt outlet on the back of this amplifier. So there is no voltage on this regulator, which are not a real regulator. There are transistors and diode Zener mounted together to give a regulation, which is very strange. There is no real regulated, as as you know, regulated regulator. This is transistors with a Zener. You can also make regulator with a Zener and resistive load actually. So I'm going to show you the back of the PCB and try to show you the harsh way to find troubleshooting on this way, because there is a lot of track under this PCB, and actually they are very, very fine, very thin layers and very fragile. Need to be very cautious, because it's always connected to the main, even if it's not working. You can see it's a very nice amplifier, and okay. So here you can see the PCB, which is a quite sophisticated PCB actually. So here you will have the soldering point from the little transformer, and this part here is the main relay, which commands this big transformer. He's waiting for an order from the remote card remote, and so you will have here you will have the bridge rectifier, and you will have here the main capacitors. The main capacitors gives to you 90 volts actually, and they are nicely filtered by the process of bridge rectifier and capacitors, and it presents no damage actually, even if at first glance we found a bad sine wave on the scope. So this power supply is going through this transistor which I was showing to you earlier, and there is also the second transistor here, and the big black transistor which was add with some diode and resistors to make a regulation was this one. Maybe it's not possible to see it, but although those transistor was dismounted and tested on the little tester to see if they are really good or really bad, because you found very exotic voltage, even if you are very nice practice of the multimeter. So to make it very sure, I dismounted all this component. And to go to the chase, I'm going to show you a very unusual problem. So as you can see here, and this is the main reason I made this video, you can see here there is a correction of engineering. As you can see here, you can see a correction of engineering circuit, which is actually a strap, because they need aftermath to make a strap, because they need to connect some mass between them, some ground between them. If this is a correction, I guess this is actually a ground, maybe a ground. If I'm not wrong, this is maybe a ground. And as you can see, they put a kind of compound here, which is a nasty compound actually. And during my troubleshooting, I was testing and using a very sharp eyesight to see if there is any broke circuits on this very thin track, which is very hard to check actually, because sometimes they can have some little failure, and you can see it with the naked eyes, even if you have microscope. Or so the troubleshooting was to check randomly the track, yes, because I had to make this stuff randomly, looking about the track, if they are nice or not. And of course, I was checking this little capacitor here, which is this one. I don't know if you can see here, C854. These capacitors present a voltage of 6 volts. And after regulation, because this part here is the black transistor with the Zener diode and the resistor, and this part here is a regulated power supply, giving nearly 6 volts to this capacitor here. And of course, I was in my lucky day actually, and I decided to follow this track and make continuity tests between the start and the remote card here. Of course, in this area you can see here, there was the same path that you can see here, and actually what happened on this path, it's because the track was underneath this the it make some strange reaction with the compound until the copper was destroyed by this special compound. This is not the first time I see damage coming from a compound like this. It happened to me on Logitech speakers, which was completely destroyed by a compound like this. So I was on my lucky day and I scratched this compound here, and I found a broken track underneath the big compound which was here. I snatched completely this compound, and you can see here. You cannot see very nicely, but I'm going to use the microscope. So now we are under the microscope, and you can see obviously dead track here, which is actually the compound began to destroy other track also, and of course this track was partially destroyed, which was giving a very strange behavior, working but not perfectly working. So if I show you the first compound here, it was exactly the same like this one on this area, which destroyed completely this track. So actually this track is coming from the capacitors with the 6 volts on the leads, and this capacitors was intended to supply the logic board with the infrared board. So of course this trouble was discovered during a random test of track, because tracks sometimes are very difficult to check, because sometimes if there is a disrupted track, it's not visible at first sight, or with naked eyes. It's very difficult to make this kind of trouble. So it was my lucky day, and I scratched this compound, and underneath this compound I found this broken trace. So what I'm going to do here is to repair this trace again, because I already made some little tests with a little wire here to test if the trouble was coming from here. So we're going to, for the video, I'm going to do this again, and see how this power supply, this amplifier will react. Okay, just scratching a little bit this mask, because this mask is used, of course, to protect the copper. And if the compound destroys the mask, it can make shorter the life of this track, actually. As you can see, actually, exactly in this area, there is no more copper. And it's very difficult to find this kind of trouble. Let's do the job correctly. Of course, the amplifier is disconnected from the main. And let's tune. Let's make some tune here. It's enough for the job. Of course, the perfect thing is to have some varnish to apply after soldering, but unfortunately I have not this varnish to make it very perfect. So I need a very thin wire, which is here. I'm going. of course, the flux helps a lot to make it right. So, okay, I'm going to change the flux because this one. This one is not the same flux. As you can see, it reacts very differently, because sometimes when the wire don't want to be okay with the solder, you need to change your, and of course always cleaning, because some flux are conductive. It can give some trouble if you don't clean the area you are soldering. So, okay, it's done. Just cutting this one. Okay, actually it's very easy to do, but the very harsh thing was to find the trouble coming from here. It's really a lucky day. A little bit of isopropyl alcohol to make it very clean, because those residue can be very conductive, because the second flux I used here was absolutely not for electronic purpose. Don't be mistaken with this kind of flux, because this flux is very powerful and is able to make some short. Be very careful with the flux you use. So, okay, the strap is made here. Okay, you can see the chin of the solder is not very perfect, because it was attacked by this kind of compound, which is very nasty actually. I don't know why they use this kind of I think this is for a mechanical purpose, to maintain this wire correctly on the PCB, but this is an unexpected behavior from this compound. Okay, so let's see now how the amplifier reacts now. So now this amplifier is in front of you and in front of us, to try if there is some different behavior. Of course, I have this power supply. Off, which I'm going to switch on. If I can. Okay. Okay. Let's switch on the power supply. I can see it's on maximal protection, and let's put a mean voltage. You can see there is no current, and you can see here there is a change. Actually, the LED of the button is working. The LED is working, which was not the first case. It was the case the first time I plug it on my bench 4 days earlier, but it never worked again, and so I was very lucky. So to make a real test, I will change the power of this power supply, which was firstly at the maximum protection, and you can see the integrated power supply, integrated amplifier is working, and you can hear the click of the relay, which is connected the main integrated circuit to the output speakers, and you can see here the CD input, which is showing you here, and video aux, tuner, phono, and tape. And of course you can switch off, and you will have the standby LED. and it indicates to you that then the trouble was mainly coming from this very little track, and it's a very ominous trouble actually, and this is the reason why I made this video, because it's very interesting to share where the problem comes from. And in my case, if I didn't snatch this compound, and randomly, if I didn't make some tests about the track, continuity of the track, I will not found this trouble, because actually visually at first sight, first glance, there is absolutely no damaged component and other stuff like this to send me at the first place for beginning troubleshooting. I'm not familiar with this kind of repair. I usually make some different repair on different devices, and I'm not specialized on specific equipment. I sometimes try to fix very different devices, and for me it's a real pain to try to understand how some device work to try to make some troubleshooting. Actually, I found this little track which was disrupted, and all because this nasty compound. So now, if you are looking for a trouble on any PCB, and if you see a compound, be aware about the compound. I hope you like this video. It was Alexander again, and until you see you soon.